Every piece of plastic ever made still exists somewhere on Earth. From the very first plastic combs and toys to the packaging we use today, nothing truly disappears. Instead, it lingers, breaking down into smaller and smaller pieces, but never really going away. The candy wrapper from your childhood, last week's water bottle, they're all still out there. These everyday items, so easily tossed aside, become part of a growing legacy of waste. Each piece tells a story of convenience, but also of consequence as they accumulate in places we rarely see. Plastic's durability, once a marvel, is now a global crisis. What was once celebrated for its strength and versatility has become a symbol of our throwaway culture. Mountains of plastic rise higher each year, overwhelming landfills and recycling centers alike. It's in our oceans, our soil, even in remote rain and the deepest seas. Microplastics drift through the air we breathe and the water we drink, infiltrating every corner of the planet. No ecosystem is untouched. Even the most pristine environments now bear the scars of plastic pollution. This isn't just litter, it's a crisis we all helped create. Our daily choices, multiplied by billions, have led to a problem that feels overwhelming. But it's also a problem that connects us all, regardless of where we live. But science thrives on big challenges, and this is one of the biggest. Around the world, researchers are racing to find solutions, driven by the urgency of the crisis and the hope for a cleaner future. We produce hundreds of millions of tons of plastic each year, much of it single-use. These items are designed to be used for minutes, yet they persist for centuries. Factories churn out packaging, utensils, and containers at a staggering pace, feeding a cycle that seems impossible to break. Imagine garbage trucks full of plastic circling the Earth. That's our annual waste. Every single minute, the equivalent of a truckload of plastic enters our oceans. The scale is almost unimaginable. Yet it's the reality we face. Wildlife chokes on it, and the problem grows daily. Sea turtles mistake bags for jellyfish, birds feed plastic to their young, and countless animals suffer from our discarded waste. The impact on biodiversity is devastating, threatening entire ecosystems. Yet plastic is essential. It keeps food fresh, cars light, and saves lives in hospitals. Its versatility and affordability have revolutionized industries, making modern life safer and more convenient. But this very usefulness makes the problem even harder to solve. We can't just wish it away. So what do we do with it? The challenge is daunting, but it's one we must face together. Our future depends on finding new ways to manage and reduce our plastic footprint. Recycling sounds simple, but with plastic it's anything but. Different types of plastics require different processes, and contamination makes recycling even harder. Most plastic is never recycled at all, ending up in landfills or the environment. The process is complex and hasn't made a dent in our plastic mountain. Despite decades of effort, the pile keeps growing, and the world is searching for better answers. But what if we could transform all that waste into something valuable? Imagine a world where plastic isn't just a problem, but a resource, one that can be turned into fuel, building materials, or even new products. A new scientific breakthrough is showing us how, and it could change everything. With innovation and determination, we may finally have the tools to turn the tide on plastic pollution, giving our planet a chance to heal. Why is recycling plastic so tough? The answer lies deep in the world of chemistry, where things get complicated fast. Unlike materials like glass or aluminum, which can be melted down and reused almost endlessly, plastics are made up of a vast array of different chemical structures. Each type of plastic has its own unique formula, and that makes recycling them a real challenge. The word plastic actually refers to a huge family of polymers, long chains of molecules, each with its own recipe and properties. From the water bottle you drink from, to the packaging that keeps your food fresh, to the toys kids play with, each item could be made from a completely different type of plastic. You've probably noticed the numbers stamped on the bottom of containers, like PET, HDPE, or PP. These codes aren't just for show. They tell recycling centers exactly what kind of plastic they're dealing with, because each type needs to be processed in a different way. Mixing them up can ruin the whole batch. Imagine trying to bake a cake by tossing in random ingredients without a recipe. The result would be a disaster. And that's exactly what happens when different plastics are mixed together during recycling. The end product is often weak, brittle, or completely unusable. That's why sorting is so important. But it's also expensive, time-consuming, and often done by hand. Workers have to separate plastics by type, color, and even by how clean they are, which slows down the whole process and drives up costs. And then there's contamination. Leftover food, sticky labels, or even a little bit of grease can make an entire batch of plastic unrecyclable. These contaminants interfere with the recycling process, turning what could have been a new product into waste. Some plastics, like PVC, are even more problematic. When heated, PVC can release toxic chemicals that not only damage recycling equipment, but also pose serious health risks to workers. Because of these dangers, most recycling centers won't even accept PVC. Instead, it's sent straight to landfills, where it can sit for centuries without breaking down. Even when we do manage to recycle plastic, it's usually what's called downcycling. That means a plastic bottle might get turned into a park bench or a carpet fiber, but it can't become another bottle. The quality drops each time it's recycled, and once that bench or carpet reaches the end of its life, it can't be recycled again. It's a one-way trip to the landfill, where it joins the growing mountain of plastic waste. Mechanical recycling, the most common method, can only do so much. It's a physical fix for a chemical problem, and it doesn't address the underlying complexity of plastic's molecular structure. To truly solve the plastic problem, we need smarter solutions that can break plastics down at the molecular level and rebuild them into something new. Scientists are working on innovative ways to tackle this complexity, but there's still a long way to go. So far, traditional recycling methods have barely scratched the surface. The vast majority of plastic ever made still exists somewhere on the planet, often in landfills or polluting our environment. With plastic waste piling up in cities, rivers, and oceans around the world, it's clear that we need a breakthrough, a new approach that can handle the messy, mixed reality of our plastic use. That's where cutting-edge science comes in. Researchers are developing new technologies that could transform how we deal with plastic waste. Let's see how these innovations might finally crack the code of plastic recycling. Scientists have tried chemical recycling, breaking plastics into their original building blocks. Pyrolysis, for example, cooks plastic at extreme temperatures to make crude oil, but it's energy-hungry, expensive, and complex. It works best with sorted plastics. Mixed waste and PVC cause toxic byproducts. Sorting and cleaning are still required, defeating the purpose. These methods were steps forward, but not the silver bullet. We need a process that's simple, efficient, and handles real-world unsorted waste. That dream is finally becoming reality. Enter Professor Maschmeyer's team at the University of Sydney. They created a one-step process like chemical surgery for mixed plastic waste. Their method uses high temperatures and a special liquid catalyst in a single reactor. The catalyst helps break plastic chains cleanly and efficiently. This process handles a mix of plastics, including PVC, neutralizing harmful chlorine as harmless salt. No more meticulous sorting. Years of research led to a scalable system, turning local waste into local energy. It's a game changer for global plastic pollution. Here's the secret: supercritical water. Heat water under high pressure and it becomes a powerful solvent, supercritical water. Shredded, unsorted plastic is mixed with this water in a reactor. At 300–400 degrees Celsius and high pressure, plastic chains break apart. The catalyst guides the reaction, turning plastic into valuable hydrocarbon liquids. Fuel. Chlorine from PVC is trapped as harmless salt. After the reaction, the mixture cools and separates. The oil is collected, water and catalyst are recycled. Inert leftovers are removed. The result: high-quality liquid fuel from plastic waste, in one efficient step. No need for perfect sorting or cleaning. It's a clean, controlled process, an elegant solution to a messy problem. Efficiency is key. How much plastic can we actually transform into something valuable, like fuel or useful chemicals? For years, scientists and engineers have been searching for ways to maximize the amount of plastic that can be recycled, aiming to turn what was once considered waste into a resource. Old methods, such as pyrolysis, could only convert about 50 to 80% of plastic into fuel. That meant a significant portion, sometimes nearly half, was left behind as unusable residue, which still needed to be disposed of, often ending up in landfills or incinerators. But now, a breakthrough process has changed the game, achieving an impressive 95% conversion rate. This means almost all the plastic that enters the system is transformed into valuable products. Imagine this: For every 100 kilograms of plastic waste collected, 95 kilograms are turned directly into fuel or essential chemicals that can be used in industry, transportation, or even to make new products. Only a tiny fraction, just 5 kilograms out of every 100, is left as residue, drastically reducing the amount of waste that needs further handling or disposal. This leap in efficiency completely changes the economics of recycling. With almost all the value now being recovered from plastic waste, recycling becomes not just environmentally responsible, but also financially attractive. Companies and cities can now see real profits from recycling programs, turning what was once a costly problem into a valuable opportunity. Instead of paying to dump plastic, they can actually earn from it. High efficiency means less waste piling up in our communities, more energy being returned to the grid, and a powerful new incentive for everyone to recycle more. It's a win-win situation. The environment benefits from less pollution and cleaner landscapes, while the economy gains from new sources of energy and revenue. By unlocking the energy stored in plastic, we're making recycling not just possible, but truly sustainable for the long term. This innovation is a major step forward on the path to a circular economy, where materials are reused and nothing goes to waste. With these advances, the future of recycling is looking brighter than ever, full of promise for both people and the planet. This breakthrough does more than make fuel, it powers a circular economy. End-of-life plastics become valuable feedstocks for new products, not just landfill. New facilities mean green jobs and new markets for waste collection. For island nations, it turns pollution into local energy and independence. The process is safer and cleaner than incineration or landfills. Harmful byproducts are neutralized, not released. It's a responsible way to manage even the trickiest plastics. Most importantly, it proves that science can solve massive challenges. Waste is only waste if we fail to use our imagination. This is hope in action. The journey from pilot plant to global adoption isn't easy. Scaling up requires investment, engineering, and regulatory approval. The catalyst is effective, but researchers are working to make it even better and cheaper. Fine-tuning could let us target specific fuels or chemicals as needed. There's also the big picture: burning the fuel still emits CO2. This is a transitional solution, managing existing waste while we shift to renewables. The first commercial plants are coming soon. The science is solid. Now it's about implementation. The hurdles are real, but solvable. We're on the cusp of real-world impact. Turning plastic into fuel is a triumph of teamwork and ingenuity. Chemists, engineers, and entrepreneurs joined forces to solve a global problem. Science is a team sport, and every breakthrough is a win for humanity. This technology is a cornerstone of a circular, sustainable future. But technology alone isn't enough. We all play a role. Reduce single-use plastics, choose reusable products, and support smart policies. Small actions, multiplied, drive big change. Let's be inspired by this breakthrough and do our part. Support science, advocate for innovation, and make conscious choices. Together, we can turn the tide on plastic pollution. We can clean up our planet and fuel our future. Change is possible if we work together. Let's get started.